Consider the graph of y equals f of x, which is drawn below. Let a of x be defined by the integral. A of x is the integral from -1 to x of f of t dt for x between -1 and 6. So in other words, this function is to do with the area under the curve, starting at this point here. It is known that a of 2 is 15, and that tells me the area under this arc of the curve is 15. We also know that a of 5 is 0, which means the area in this loop must also be 15. Because it's below the axis, it would come out on an integral as -15, and that's why we get to 0 at 5, because we get 15 take away 15. And then a of 6 is 8, so there'll be a part of the curve here, and the area in here would be 8. Sketch on the axes below the function a of x for x between -1 and 6, labeling clearly key features such as x-intercepts, turning points, and inflection points, if any. Okay, so we know that when we're here, we have an x-intercept because the integral from -1 to -1 would be 0. We also know we have an x-intercept just there. Now, all the time we're going across here, we would be gaining area. So the maximum area must happen when we get to 2. Now, we also know that that's 15. Now, up until this point, the rate of increase of area gain is increasing. But once we're past there, the rate of gain decreases. So we're going to have an inflection point along there.